Can I present my screen?
Repeat again.
Can I present my screen? Because I need to.
Why you need to present your screen?
Because I need to show something because my code is okay, but the output from
you're having problem on which software?
PIC SimLab, because the PIC SimLab
can we do that during the end? So can I complete first the briefing?
Okay.
Any other question other than your setting the software? Ada soalan? Do you have any question? Okay, ada soalan? Any question related to the briefing for software part? Try to wait during the when I complete the briefing. Okay, tak ada no question. So we continue looking at module 1B. Okay, like I said, no need to do report for module B. Module B only for introduction to give you some exposure to the software, how they be used throughout this semester, throughout this course. Okay, so we look at module 1B. So this one will give you introduction to the software. This MPLAB X IDE and also X8 compiler. So if you have already obtained the software, you can continue installing. If you successfully install the software, so this is the icon. So this one for MPLAB IDE. This one is not related. One related to software part, but the software in concern is this one, MPLAB X IDE. Okay, so provided you successfully install these two software, because these two software need to work together. If you don't have either one, if you don't have this, you cannot write. If you have this, you can write, but you cannot compile. Okay, so need to install together correctly. And then the objective to give you exposure for this software, MPLAB X, so X8. X8, and then equipment going to be using is the software MPLAB X IDE, compiler X8, and then computer. Everything need to be inside this computer. So brief introduction related to the software, which is MPLAB. So the software can run on different operating systems such as Windows, Mac, or Linux. So you can develop program, especially since you are using MPLAB. So basically, this one will involve with PIC microcontroller. Okay, so the software is called IDE, Integrated Development Environment, because of the single integrated environment that you can use by developing the software for the embedded, and then you can compile and then you can program everything you can achieve within this software. Okay, so PIC, so you can use PIC with MPLAB X. Other than PIC, is unusable. Okay, only work with microchip IC. However, not all microchip, all PIC microcontroller is available. You need to read carefully on the selected PIC microcontroller. And okay, this is like I said, for MPLAB X8, you can use it with 8-bit PIC microcontroller, such as PIC 16F8778. Okay, so PIC 16F, you need to use X8 compiler. Other than that, such as a 16-bit MCU and also this DSPIC, need to have their respective controller. For this one, XC16, and then for higher version, more sophisticated controller, we have the 2-bit. And for that one, the compiler related compiler would be this one, XC32 or 32++, depending on the supported model. So the environment is in the form of graphical. Can be user easy to access. So everything specific function have their own icon. You don't have to search anything. So everything that you would normally use, you can access through icon. Other than that, graphic, the writing of the compiler code, everything will be represented by the specific command. We will see later. Okay, so how to use? So basically, double click this one first. So you can see, right now nothing. Right now nothing. Ignore other software that is not related to MPLAB. Okay, so only observe this one. Okay, so MPLAB XID, double click. If no problem, you can see introduction. The introduction icon will appear. So loading, loading in progress. If you have a sophisticated software, this one will be faster. Okay, but my computer is very old. Okay, need to wait till loading complete, and then you can also window. Okay, so once loaded, so this is the MPLAB X IDE software. Okay, so this is the version, the current version that I'm using now, version 6.00. So this one is additional if you are using PIC SimLab. Okay, once you have execute the software and the software is successfully loaded, you continue by clicking PIC SimLab. Okay, but right now I will not show you PIC SimLab, but just to show you the flow. Okay, if you want to simulate using PIC SimLab, the flow must be load first the MPLAB X IDE. Okay, if successfully loaded, then you can continue by executing the PIC SimLab. The flow must be that particular order. Okay, so this one is successful. So you can see here, this one version 4.10, an older version. The difference is not much, but you can observe some of the specific function. That one I will explain later. Okay, so basically, in order to write the code, code executable by target controller. Okay. So how to do that? You need to load the source file, okay, which contain the program, the code. Okay. Load that to PIC. How to download? Later on we will see. Okay. And then need to use selected language to assembler, PIC assembly and so on. Okay, and then make sure correct compiler. So some of the basic steps that I will show you will be how to create project using the project wizard. Okay. Language tool. Okay. What kind of language you want to use? And then we want to add, if you want to add extra file. So what is the benefit of the extra file? What is the function? That one I will explain it. And this code. Create code by writing. By writing together so that the writing part has been covered during our last lecture. And then test code. Okay, this one if you are using the kit. Okay, if you are using simulation, which is PIC, you can run. Okay, that one I will show you later how does the function operate. Okay, so we go to part B, creating a new project. So how to right now. So this is the initial part. Okay, this is the most important. The starting of the part. You need to follow the procedure by start a new project. So different program must have their own specific project. So you go to start page, go to file. You can observe from this one. So right now we just look at, then after that I'll show you what. Okay, so you need to go to file, new project, and then select, choose project. Whether this is the option. Okay, so when you go to choosing project, so these are the option that is available. So make sure that you select the first one, which is the project. And then other than that, included here, other project, simple project. Okay, so, but for beginners, okay, try to follow this one. Okay, you go for standalone project, and then okay, so for PIC, for our lab, need to follow standalone project. Okay, so this is the icon. Okay, once you have clicked new project, so you can see here. Okay, so you can see here a new menu will appear. So this one shows you that you are at the first step. Okay, so the first step is choosing the right project. So go for standalone project, and then select device. Okay, select device through here. Okay, so this one is at second step. So the step has been carefully tabulated. Okay, so and also you can see your current step. Okay, so right now the current step is at number 2, select device. Okay, so how to do this? You need to select the correct one. Okay, so since we are using with this PIC of Chile throughout this semester, so need to choose this one. PIC 16F877A. And then this is an older version. So that's why if you are installing new version, you will see new selection here. Okay. So like I said, older version have different setting. But if I'm using new version, you will see new selection appear here. That one you will see later. And then after that, select programmer. Represent by figure 6. So you can see from here. Okay. With coming together with color coded. For hardware tool that can be used either for debugger or programmer. So the required programmer you can type of selection. And then after that, select PIC kit 2 as the programmer shown in figure 7. Here, hardware tool. This one only if you are using the kit, okay? Because this one is related to the hardware. Since we are using PTK 48 kit, that one is hardware unit. The programmer is called PIC kit 2, the software that works together with programmer. So if you want to use hardware, you need to select this kit. Okay? Other than that, pick select, that one I will show you later. Okay? How to select pick select, because that one will not involve any physical hardware. Also, when we are not using physical hardware, the software here will not be involved, will have no effect. And then select the compiler. Okay, this one. Select the correct compiler. 8-bit, choose 8C8. And for this course, our controller will, our microcontroller is the same throughout the rest of the semester. So you need to choose XC8. And then click next. Okay. Once you have satisfied with your selection, go on to clicking next. So right now, if you look at this figure, okay, from 7 step, the current step is at number 6, the selection of compiler. Okay, so here, okay, once you have selected, that particular compiler will be displayed here. Okay. You can proceed by clicking next. And then after that, you need to start. Okay. So this part, starting from step number 4. Okay, step number 4. The part for configuring your hardware is completed. Okay. So right now, the next step will be the selection of the program file, how to write the program file, how to load the program file. We'll start here, starting from step number 5. Select project name and also folder. Okay. This one, the continuation from this one. So from this one, you need to select folder and also project name for your project. So enter project name and also location of the folder. So try to make it standardized. Everything that's related to PIC folder, to put it in a single folder so that you can access that particular project later on. Okay, browse to a folder location. Okay, so this is the default one. The username, then that project. If you however you have other alternative, you can do it also. And then check set as main project to specify the project as your main project. And then location. So you can see from here. You can see from here. Set as main and then the project location and also the folder from here. Here. And then encoding, the encoding part, this one, part. Semua boleh nampak, everyone can see. And you can see this cursor, my mouse cursor.
Yes, sir.
Okay. We have also some track. And then, okay, so this one, okay, if you look at the step, this is the last step, the selection of project name. And right now, the current step, the last stage. So write down the correct, the suitable name. Make sure that it's related to the program. And then the location. So if you have multiple projects, so you can put it in a single folder so that you can access your project. And then project folder, this is the location. Okay, this is the project folder location and then folder. Browse and select the project folder. This one is related to the project. This one is the location where your project will be put. Okay. The location is here at tutorial for this example for this main one. And then this is your test project. Test project location. Related to the project. And then make sure to click this one. Set as main project. And then encoding, this one. So what is the significance of this code? From the command. If it give you proper visualization of your code, such as font, color, syntax, tag, so on. And then after that, in every project, make sure that this one only related for hardware. For software online, this one the project, the location, all will be located in your computer. So feel free to name any name that you like. Okay, but for this one, since you are using our lab computer, so you need to follow this command so that we can easily identify your project. And then project name module 1 can be created for column for project name when you have successfully select configure. You can click the finish button here. Finish button here, and then as in figure 10. Okay, so once you have finished all the setting, review the project window in lab environment. Okay. The figure should be something like this. So you can see here. Okay. So this is the module 1. Every time you create new project, that particular name will be displayed here. Okay. So right now we don't do anything. Okay. So that's why everything here is basic. And then if you are looking down, so you can see here your previous setting, what type of microcontroller you are using, the compiler, everything shown here. So just you once you have click the finish button, your setting will be displayed here. And then debug tool, this is the kit that you are going to use. And then so you are seeing nothing here, okay, except for the home window, okay, because you are not starting or you are not writing any program yet. Okay, so that one will conclude on the setting up the project. So we will go to writing your code. So the first thing need to do after you have successfully set the project, you have set up the project. You can go to source file. Okay, click here. Okay, file new file. Okay, and then go to the next one. New window in figure 13 here. Okay, once you have click this one, click new file. So you're going to see new window here in figure 13. So this one, you need to select correct configuration of the file that you are using. Okay, so make sure to follow this setting. Choose C main file. Is here. Location is here. And then this project located in module 1. Okay, and then after that, nothing located here. So you click, proceed to the next, and then after that, you need to set source file name. What is the name of that particular file? Okay, so since that file is in the form of C source file, so the language is C. You need to write down your program everything in C language. And then after that, you name your file. You use module 1 as file name for this source file. So you can module 1 doesn't have to be similar. Just as long as you know what is the program. And then as the file name for this source file, the given name will automatically have extension. Okay. So if you are writing module 1 and then dot, the format is .c. Okay. So automatic, no need to write everything here. Just you need to select. Okay. So essential here is NC. The file name is module 1. So when we review, after this we review, the file will be module 1.c. Module 1.c. And then, okay, so like previous step, there are also steps shown here. Okay, starting from the first one, using the file type, and then after that, right now the current step is at number 2. Okay, name and location of your file. So you need to specify a folder. So you can see here the file and the folder better put in the same place, same location. And then once you have completed, click finish. And then so if you refer your select window, so if success, you will see here new file here. Okay, so this is what I mean by module 1.c. So if you correctly set, the name will be the module 1.c. And then okay, but need to know okay, the file is already available but not the program. So this you need to write down the program. So the other way to create new file is go to this one. You can also other than clicking, click file here. You can also click the source file. Okay, it is here. This one. Okay. Left click to select your selection, and then click right. Okay, to make the option, the new option window appear here. Then you can also set from the setting. Left click to select, and then right click, new window, and then choose main.c. Similar like previous step. Okay. And then after that, you need to configure, okay, such as by setting the path then naming the name, naming the file. Okay. And then for part D, write and build program. You're going to look at first how to write and after that how to build that particular program. Since we are using C, the program language, the first is to writing pre-processor directive, such as define, hash include. So normally this type of directive need to be placed on top of your program structure. So can be any order, either define or either include. So you can put any order just as long as it is placed on top of your program. Okay, so what is the purpose of basically for include? Okay, so include normally you are attaching an extra program, not written in your program, but written on the respective location and also file that you are putting together with include. So the advantage is that you don't have to rewrite in your actual code, or just as long as you have this file, you can include. Okay? So when you want to use it, you just call the function. No need to write anything. How does the function flow? How does the processing flow? How does the calculation operate? You just call the function on it. So that include. Define the relative, so field text for the specific identifier. You need to define specific identifier. And then other, so since you declare, okay, declare name and also based from our previous lecture, name and attribute of your variable. Okay, function type, what is the function? The subroutine function that returning any value. The type used for the variable, okay, whether it is a constant variable, whether the variable is integer, char, short, so on, okay, the format, the data type, and then global variable need to be declared outside the function. You need to declare the variable, provided that if you want to use the variable for every subroutine, every function, normally you need to declare inside that particular subroutine or particular function. But if you use global, no need to define. Okay? So you just define on the first statement, and then after that you can call, provided that the one is global statement. For private, you need to re-declare, okay? Every time you have new subroutine. And then y, okay, establish the content size. And then statement control flow on the order. Okay, so like I said, the start here. How does the flow happen? Okay, starting with the first one, second, and going down at the bottom, the last one. Okay, all C program must contain a function and name main. Okay, so you know what main is. You already seen the example. So the function name here is where the program execution is. Okay, program execution. Okay. So the program braces enclosed in the main function define the beginning and the ending of the program. So the braces is the curly bracket, okay, which is here. The curly bracket, open and close. So everything written here, any code written here, within the end, after the end, and before the closing curly bracket will be executed. Okay. Why? Because after the program being executed, the order will be on the top. Then after that, it will go to the main. The main will execute this one. Basic program, basic code, basic routine. Program execution begin, and then this one when we dealing with the key itself, you can also make adjustment. You can also use program in the previous example that we see here. You can also copy and then paste it in the module. So retype, make sure that you check all the semicolon. The code is sensitive, either toward the character, the special special character. Okay. If the program require semicolon, you need to put semicolon. Like you see here in this example one, so you can see here. Some code don't have semicolon. So normally semicolon you put after your program, okay, like this one, and then double slash to indicate command. This one does not have any effect on the program itself, just for information. You can write down anything, okay, provided that you put double slash before your text, or you can also put sometime if you remember, you can put here forward slash and also star, and then for closing part star then slash. Anything written within that character will be considered as comment. Does not have any effect on your program. And then once you have completed, save the file and go to production build project. Okay, the output window will show result build process seen in figure 18. Okay, provided that there are no errors. So if you're using PTK48, you can proceed with downloading programming. Okay, so this is figure 17. Okay, okay, so first thing, check first whether all the notation, the character correctly typed. Then you go to this one. This one production build. This one build your project. Build your project here. If you don't know, you just put your cursor here, so you can see here a new indicator shown here. Build main project. If you click, it will start building your project. So once you have clicked here, this is your program. This is your program. So you need to observe this part. Once you have select, once you click the icon, build project. So some information will be displayed here. Okay, so need to focus this one. Okay. If there are no errors, you can see here, build successful. Okay. So it's build successful. You can see here, okay, new file. This is what I mean, okay, which is text file. Okay. Only created when the program is successful. If not success, this means that your program contain errors. So you need to go back to this section to locate the error and also correct the error. Sometimes the error will explain okay, what is the wrong with the code, okay, but you need to locate first in order to correct in order to do correction. So the zoom part of this part of this section, you can see here. Okay, so need to be sensitive with part the status. It's successful. Okay, so successful means that you go on to writing up the program. Okay, so this is example one. You can try this example one. This one, so you can see the flow here. You start by including compiler, and then this is the configuration of the PIC. So you need to specify. Okay, you need to enable because this one is contained on the microcontroller. So whenever the microcontroller is turned on, the microcontroller will go setting up the setting, the configuration. So you need to follow the setting here, and then this one. If your clock frequency is 20 megahertz, you need to put the correct value. How? From your hardware, from your design. Which how many what is the frequency from the crystal oscillator, the external, not internal, the external. If you are using 8 megahertz, change it to 8 megahertz. But this program work with 20 megahertz. Okay, so you are defining the name here is fixed. Okay. You need to follow the name here, the name syntax. Starting by hash, define spacebar, and then underscore extra, uppercase, and then print. Then spacebar, need to put 20 megahertz. And then this is the variable, the global variable. Why? Because after this, you're going to use it. Okay. The variable we will call here. Let's say you have another function. Okay. So that function can also use this variable. Why? Because it's global variable. It is declared outside the program during the initial stage. Also, we have another one, J. So I and J is the variable unsigned. Unsigned means positive number only. Okay, char, what is the char? Range between 0 to 255. If you want your variable to store more than 255, put either int, long, float, double, so on. Okay. Make sure that the size is appropriate with the size, with the value of the variable, because we want the processing speed to be fast. Okay. We want the processing speed not affected with the selection of the variable. So you can start with this is the main program. Need to follow the naming convention here, and then open and close curly bracket. So you write down everything that you want your code, you want the microcontroller to do. Okay. Within this subroutine. So trace D, port D. So trace D is the direction of the port D. Okay. We know that PLC F877A contain port A, port B, port C, port D, and port E. The bit size is different, okay? Especially port E. I think port E around 3 bit. So you can see here how many bit? 1, 2, 3, 4, 5, 6, 7, 8. So port D have 8 bit, so you can use port B. If you're using port E, it will be trouble because 8 bit. Okay. So first, if you want to use port D, you need to define trace D. Okay. You need to define whether trace D is input or output. If you want port D to light up LED, so this means that output going out from port D to LED. So this means that it is output. If you want port D to scan for input from switch, so this means that signal from switch will going into port D. So this means that trace D must be set as input. So how do we set input and output? That one I will explain later. Okay, to be continued. Okay, right now for output, put everything 0. Why 0? Why everything 0? Why 8 bit? Because we have 8 bit of size for port D. Okay, so this means that starting from RD0, RD1, RD2, RD3, RD4, RD5, RD6, RD7 will be set as output. If you want to use a specific location, you can also put this part. Okay? Other than that, no need to rename anything. But the convention must be correct. Okay? And then after that, once you have specified as output, you go by clearing up initial value for port D. You setting up port D as 0. So it means that any value happen exist before the program, it will be clear, it will be delete. Okay. So put new value. This is in binary format. Okay. Why? Because 0B, it can be 0 capital B, or it can be 0 small case b. Okay. So you can see here, okay, this is O, this is O, this is 0. Try not to be confused. Try not to mix up. Okay. If you put OB, so when you compile, it will cause error. Right now, this one need to be in numerical, in number. So right now for I, the initial value of I is 1. the initial value of J is how much this. Okay. You know, you can click on your calculator, make sure that the mode is in programmer, binary, binary. So 1, 0, 0, 0. Okay, this one is 8. Okay, and proceed because located on the 7, on the 8 bit location 7, so 80, 80 hex, or 1 to 8 decimal, or octa 200. If you don't know, you can use this one. So this means that we are assigning value 1 to I, then 1 to 8, 1 to 8 into J. Okay. So this is the continuous looping. Okay. So you can see here the structure. While means true. Okay. And then you have double slash. Okay. So contain some statement identification. So this is the sub program from this the whole program. Sub program whereby this is the continuous looping. And then I current value is 1. So you shift to the left 1 bit, and then you shift to the right 7 bit. Shift data from left to right. And then for J, shift to the right 1 bit, and then shift to the left 7 bit. So they are ORs. So this means that this one is single OR, it's not double OR. So this means that bitwise operation between 1 and also 7. Shift data to the left, shift data to the right. Shift data. This one shift data to the left. Shift data to the left from left to right. This one from right to left. And then you display. Okay, you display port D by OR, by bitwise OR, I and J. The final value after completing the process here, new value of I, then new value of J, you need to OR again. Okay, and then after that, wait around 200 milliseconds. So the value from this process will be transmit through port D. And then this one exercise. If you want to do, you can do. If you don't know, you can ask. Okay. So but right now, you don't have to submit any report. This one just exercise. Okay, that one will cover MPLab X. Any question related to MPLab X? Okay. That's soalan. Not the problem as probably previously mentioned. Okay, right now related to the explanation. Ada soalan? Okay, no question. Okay, you can interrupt during my briefing if you have any question. So that one we conclude. So we look at module 1C. So module 1C related to PIC. Simulate real-time emulator simulation software. You simulation software that you want to simulate. You want to observe the output from the program. You can use PIC simulate real-time emulator. So basically, the module here will introduce you with the application of PIC simulate. Equipment needed, two software, MPLab IDE, so compiler, so everything must be installed in the computer. Okay, so brief introduction. PIC simulate is a real-time emulator for development board. What is development board? So you can see the example here, similar like this one. Okay, similar like this one. But this one contain everything. Certain the development board, they have their own specific function. Okay, so it is in the form of development board, but this board you need to configure, you need to build according to your program. So some of the SIM AVR microcontrollers, so it support other than PIC. It can support AVR. So I think right now some AVR. Okay. So PIC SimLab is integrated with MPLab X or Arduino IDE program. So you can use If you are using writing program in Arduino, you can also use PLC SimLab to observe the output for simulation purpose. Okay. So support common devices. So this means that you can build. If you refer to this module, no need. You cannot build any new function. You need to use everything that has been provided. Only use what is available. But for this one, if you want to create new kind of spare part, okay, so you can do it. Through common devices that can be connected to the board for simulation purposes. So this one for simulation only. For a typical example, LED and push button assembly to simulate simple and output input. What happens when you press switch? You want LED green to blink. Okay? So you need to build the part itself, and then you need also to write down the program. Okay, it also support Ethernet shield. W5500 for connection. So graphic display, color graphic display, which is ILI 9340. This one controller for TFT. With this one is touchscreen. So complete part you can observe from the website documentation. So how to install? Go to this location, download, and then once you have downloaded, you double click to run the installer to complete the installation process. So basically, main window shown in figure 1 here. Okay. This one contain the control board. This one is the interface. And then this one related to MPLAB. Provided that you have not installed, if you are already installed, you can skip part. You can go straight to the system tab. Okay, after you install the software, you need to install plugin. So this plugin will enable communication between MPLAB and also PLC SimLab, like a bridge. If you don't have this, so this means that you cannot communicate from MPLAB to PLC SimLab. Problem will happen because you cannot observe the simulation. Why? Because it will integrate between PLC SimLab and MPLAB. So for step number 6, once you have downloaded this the file, you need to integrate. It will not be conducted automatically. You need to do manually. So how to do this? Execute first MPLAB X software. Okay. From figure 2 here. Okay. Go to figure 2. So you can see here, this is the main window. Click tool and then click plugin. So you can see here, no project. So this means that you have not do anything yet, anything yet. So the project file, everything not available yet. So you go on first to tool and then go to plugin, click plugin, and then once you have clicked plugin, new window will appear here as in figure 3. So basically, this is the form, the view of that particular window. Click downloaded. This one, downloaded. Okay. Click tab here, and then click add plugin button, figure 4. Locate the location of your plugin file. So if you refer to step number 5, okay, once you have downloaded, you need to put in specific location in your PC. So you need to remember that particular location because you are going to search for that file later on. Okay, so once you have click this tab, downloaded tab, then see, so this one downloaded. Okay, add plugin. Click this button, add plugin. Then so this is the location of the file that you have completed from step number 5. The extension is NBM, okay, not exe. So no need to do anything for the software. The software must be executed within the MPLAB. So figure 5, this one is figure 5. Locate that particular software and then click. This one is in the language. Yes and cancel lah. Okay, just in case we have Spanish student. And then go to step 6.4. Okay, so if you have completed this one, you have completed this one. Okay, so the menu, the setting will be the information related to that particular file shown here. Okay, so need to tick PIC SimLab, PLabX debugger. So this is the info related to that particular file. And then click this one first. Tick this one first, then make sure that the file is correct, then go for install. Okay, so this means that once you have successfully installed the plugin, try to restart the software. Okay, to restart the software, execute again, and select X IDE, and then wait the window to appear, and followed by execution of Fix SimLab. Okay, the flow, the order must be nplab X IDE first, and then Fix SimLab. And then refer module B for nplab startup procedure. Refer previous module lah. Okay, so this is the example lah. Start by this one. Okay, you need to follow starting from step number 1. Okay. This one only show you step number 2. Current step. Why? Because it is related to fixing the. Okay, so need to follow module 1B. Start by choosing project, and then for step 2, this one require detailed attention. Okay. Once you have successfully identified PIC, the model of PIC is F, X77A, go on to click show all button. If you don't click this, you cannot find PIC SimLab. So make sure you click this one first. Okay. Once you have clicked this one, then you can see PIC SimLab. Okay. So if you refer to the previous one, previous module lab 1B. Okay, so you can see here, this one is version 3.20. Okay, there's nothing here. Okay, what is the part? The device available, but the tool part, okay, the tool part is not available here. Okay, so this one only happen for older version. Okay, new version, you can see new installation, which is tool. Okay, need to tick that one first. Make sure that the PIC is the correct one. 16F877A, and then go on to select PIC SimLab, and then after that click next. And then this one, provided that you have set bolting, okay, you have included the C file, okay, then you can go and copy. However, this one is not complete program. Why? Because the structure not completed, the definition, the including part, the declaration not included, just main only. So you need to complete. Okay, so be successful Okay, so be successful. One okay. This one okay. Be successful. Be successful here. Okay. Make sure that the status shown here is be successful. Okay. Once you have successfully built, then you can proceed to PIC SimLab. Make sure that the setting follow as in figure. Okay. You need to click the debug. The clock must be 20 megahertz. If the program indicate 20 megahertz, the clock also must be 20 megahertz. Okay. If 8, both setting for PIC SimLab also programming must be matched. So this is the important one. So you can see here. Okay. Make sure that you enable debug, then select clock frequency. Then make sure this one also. So one okay, still the same. If not the same, you need to select here breadboard, and then you need to choose the correct microcontroller. Okay, so that one will that one already describe what happened during the building. Okay, so if you observe figure 10, before, you need to also check this one. Okay? So you need to also, if you follow, if you refer to I think figure this one, figure 7. If you set choose PLC Simulate and then you click next, okay? So you can observe here in the main window environment, you can see here the debug tool here is PIC Simulate. Okay. Other than that, you can also see the selection of the microcontroller. But this is the important one. Make sure that the PIC Simulate program available here exists here. And then after that, okay, so after you click the icon here, okay, once you obtain the successful, you can see here. Okay, one. Okay, if the program is success, a new tab will happen. Show PIC Sim. Okay, so this means that the connection between MPLab and PIC Simulate here, this software is successful. Their communication. Okay, so this is what happened. Okay, once you have the program is successfully linked together with PICC there. So you can observe the output return, your simulation, and then if you want to disconnect, you can follow step number 8. How to disconnect. You can either use this one, debug, okay, disconnect. Okay. But before that, if you want to execute the debugger, okay, make sure first that you build first, then the status must be successful. Then you can go on to figure 10. Okay. Make sure that you click this one. Okay. When you click this one, this is what happened. Okay. You will see Fix Simulate tab appear here. If appear, so this means that program from MPLab will be transferred to Fix Simulate. And then after that, you can do the rest of submission. You can disconnect. You can do. You can change. You can change the program characteristic, so you can observe what happened. Okay. So that one we conclude the manual part. So we go for actual part. So right now you can see here, okay, everything has been properly set up. Okay. So if you want to close, so right now I close. Close first. Close our project. Close our project. So this is the what happened when you first time open execute the software. You have not doing anything yet. Okay. So empty. Everything should be empty. This is the home section, and then try to observe my cursor, mouse semua. If you cannot see, inform me. Okay, you go on to new project. Okay, new project. Okay, because we are creating new project. Okay, okay, so you can see here, step number 1, start by choosing standalone project. Okay, and then click next. Sorry. Okay, here, click next. Okay. This one need to choose. Okay. What type of family? Because I already done this, I use recently, and then I can only select. I can select. But if you have not done everything yet, so you need to search where the location of this microcontroller. Make sure that you choose. Let's see what happens. Okay. So let's say if I choose baseline. So the microcontroller available from this group is here. Okay. If that particular PIC is not located here, you go on to mid range. So try to locate 16C, whether it is available or not. PIC 877, the number. Okay, so see here. You can also click that one. And then for 2, now I see why, because only one selection only. Why? Because you need to tick show all. If you click show all, so tick that will be available. And then click next. So this is the compiler. Choose compiler. Okay, so you can see two type of compiler, but the version is different. So I choose the latest one. So you can also see this one high tech. Okay, see, so this is an older version. Last time we use high tech, and then that one is not related. Also same, and then proceed to next. Okay, so encoding, encoding. There are several selection of encoding. So choose this one. Okay, so make sure to tick set as main project and then the location. Okay, where you want your file, your project to be located. Okay, select here. Okay, select here. Okay, because I've already do this. Okay, you need to click this one. Then open. Okay, so this one already available. So no need. I put cancel. So if you select the folder will appear here. Okay, coding with location and also folder. And then name the project. Put down the project name. Okay, lab 1. Okay. And then you finish. Okay, you click finish. But since I've already do this do the configuration, so just click cancel. Okay. Only for me, provided that you have not done anything yet. Okay, so I click cancel. I can always go to open recent project or open project. So recent project will be easy. Okay, so this is intro project. Okay, so very slow. Better if you are using newest computer version. Make sure that the speed is high. Okay, so you can see here two. Okay, Y2, remove one first. Okay, so assume that let's refer to module 1. Okay, assume that referring to figure 15. This one already. Okay, this one. Figure 11. Figure 11. Okay. So assume that the header file, the C file has not been created yet. So I try to remove. Okay, so remove. Okay, so once you have successfully created the project, everything here should be empty. Okay, so you can also you can either use this one, import new file, and then go to C. Make sure that you click the source file. Okay, check again. If you are not sure, recheck. Okay. New file, refer to the manual. C source file, C. Okay, C source file, or you can also click here. Okay, make sure that make sure that you click left click first to select, and then right click new. Okay, new main.c. Okay, this one. Put down the file name lab 1. Okay, extension must be C. Okay, project folder. Okay, first the project folder is intro 1. So select folder, and then this one. If you have new, okay, if you have new, everything has been defaulted. Okay, my latest selection already included. So need to once finish. Okay, once everything is completed, click finish. But the file already been created. Select one. Just select. Okay. This is the code. I already copy the code here, and then I paste it. But for your case, you need to write down every time So the flow must be similar, like something like this. Okay, it can be pragma first and then followed by XD, the order. Okay, the order must be on top. And then you need to define the clock clock frequency. Okay, so everything 3D, I'm using port D, so 3D. So you can see here double slash. Everything is commented. Okay, so you can see here 0 to 0 means that I want port D to behave as output. If I want to behave as input, I put 1. And this is the main program, main void. Okay, main void. So need to follow the naming convention, and then delete any initial value, clear, reset. So you can see here, this one is completely different. You can do anything as you wish, provided that the program is correct. Then after a while, after main, and then go to continue looping, start with open bracket, and then closing bracket. Everything written within this bracket will be executed. Okay, so turn on LED, anything connected to port D will be turned on. Okay, so you can see here 1, 2, 3, 4, 5, 6, 7, 8, 8 bit or 1 byte. So this means that if port D contains 8 bit, so all bit in port D will be turned on. If I put 0 here, okay, what is the location? Location bit 0, bit 1, bit 2, bit 3. So this means that bit 3 will not turn on. Okay, so because I put it 0 lah. Okay, so right now I want to enable lah. I want to turn on everything for D, and then wait for 300 milliseconds, and then switch off port D again, then wait, and then repeat again. Okay, there's no breaking out statement. So if your microcontroller turn on for 1 hour, so you will see blinking for 1 hour, provided that you switch off your microcontroller. So and then okay, so you can observe, you can check the selection. It is PIC 16F8778. Then make sure that the compiler XC8, and then debug tool debug tool PIC Simlet. Okay. Before if you want to use together with PCLab, make sure that it is already executed. So right now we cannot see anything. Why? Because right now the program require connection to port D. Okay, so how do we want to observe output from port D? You go to module. This one refer to PIC Simlab. Okay, you go to PIC Simlab. You go to module. Okay, observe the movement of my mouse. Okay, go to spare part. Okay. Right now we want to observe. Output. Okay, so why this LED is blinking? Because I already tested this program, so it is embedded with previous program. If you don't have this, you can go for new configuration. Load configuration. If you want to build output, input. If you have other feature, if you want to put another feature, you can choose from this selection. You want to put encoder, you want to observe, see potentiometer, input, switches, so on. Okay, so you can choose it here. Okay, switch button, push button, keypad, and then output. This one is input, okay, and then output. So DC motor, LED. Okay, so let's say if I choose LED, okay, so this is new. Okay, right click, delete. Okay, if you want to put new, observe the movement, output. Choose this one for LCD. Okay. So you can see nothing. Why? Because you have not clicked. Make sure to properly put your mouse location somewhere very far from the current. Okay. Once you have satisfied, okay, start, click left button. Okay, so this is the LCD. Okay, so one, we are not doing this yet. Okay, we are going for right now. We try to do simple simulation. Okay, so if you want to set, okay, make sure that the mouse is located within this device. Click, right click, then go for properties. So make sure that the setting is located at port RD starting from pin 1. Pin 1 must be RD0, RD1, the order. Okay, start for pin 1 must be RD1. Okay, so here RD0, RD1. So why? Because already set. Okay, so let's say when I put RC. Okay, okay, see. Why? Because the location here is RC. So need to be modified again. So where is RC? This one, pin number 2. RC. So change it back to RD0, RD1. Put it RD1. So we need to locate where is the location of RD1. Okay, this one. Okay. So and then the active. What is meant by active? So there are two types of active. It can be active high or active low. Okay. So right now, we put the active is high. Why? Because the output here is 1. So when we want the display to turn on from signal 1, we put it as active high. This one I will explain later on, maybe next week. Okay. What is active high? What is active low? So right now we put everything high because whenever the value is 1, the LED will turn on. So whenever the value is 0, so it means that the LED will be turned off. So you can see this is the similar program. In order to observe the difference, I try to increase the delay. Okay, put it 1 second. So right now you can see the previous program, the delay is faster. So we try to make it slower. Put it 100, 1000 millisecond or 1 second. So if you look at the mouse movement, nothing happened yet. Nothing happened yet. So make sure that your program is correct with the source file. That one. And then to get my mouse movement, my mouse movement. Okay, you click this icon here, and then observe here. Observe here. So this means that the compiler is building the program. Okay, so you can see here, build successful. Okay, successful. What? See, let's see what happened. If I try to skip this one. Okay, so you can see a build fail. This means that error will exist. So you need to locate where is the error location, or you can also see here the statement shown here. Okay, so I put again the semicolon, and then every time you do change, make sure that you compile. Okay, so make sure that it is build successful, and then okay, you already build successful, and then okay, look at the cursor movement. You go to here, debug. The icon stated here debug. Okay, you just click, and then look bottom. Look bottom. Okay. Right now the tab is only 2. If the linking is correct, this success. See, you can see here, output will appear here, and then you will see another tab, pick sim. Okay. So you go to this one, so you can see okay, the delay, the delay, the new delay start to affect. So you can see here. And then what happened? Okay, if you want to modify, make sure that you press this. one, finish debugging. We want to stop the debugging, but the program is still linking. The communication still exists. Okay, let's say if I want to turn bit 0, bit 0, okay, bit 0, then here I want to turn on. Okay, everything after you do modification, try always rebuild, and then make sure that the 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 indicator must be successful. Okay, success. Then you go for debug. Okay, so this one okay, already available okay, fixing and then you go to this one. Okay, so you can see here alternate blinking. D0 off, the rest turn on. D0 on, the rest turn off. Okay, so that's it. Make sure click this one to stop debugging, and then if you want to exit the program, you can go to debug, then disconnect. So what happen when disconnect? The connection between MPLAB and this one fixing that will be terminated. If you want to reconnect again to testing to do, you restart the whole program. Okay, now we go to question 11. We have half an hour. Try to make your question very brief, okay, so that your answer can also ask, could share their problem. Okay, who is the first one? Okay, apa nak tanya dulu? Who want to ask first? Ada soalan? Mau boleh buat? Any question? Okay, so apa? Saya tunggu. I wait another 5 minutes. If you don't have questions, so that you are doing everything correct. You just proceed to doing exercise. Ada soalan? Any question? Apa nak tanya?
Sir,
Ya,
saya tak ada partner untuk lab.
masalah pribadi ni. Ada promote dah?
Ya,
Ada promote ke?
ada promote.
Buat pengumuman dekat apa tu? Dekat apa WhatsApp group ada tak?
Tak ada sebab hari Khamis saya seorang je tinggal yang tak ada partner.
Cuba promosi tu tengok. Dapat sambutan.
Alright. Okay,
Apa kelebihannya kalau partner dengan awak ni? Bagi sikit kelemahan. Kebaikan, benefit
saya
nak promosi kan, nak tarik perhatian, nak bagi promosi yang menarik ya. Kelebihan dia apa dia kan?
nanti saya buat.
Internet kat rumah dah juga. Cuba ni lah. Cuba apa tu? Cuba apa buat pengumuman dekat ni lah. Dekat WhatsApp group. Kalau tak mendapat sambutan, beritahu saya lah. Mungkin kita buat waktu bagi pelonggaran lah. Mungkin buat seorang ke, atau mungkin buat 3 lah.
Okay, thank you sir.
Ya, sama-sama. Next question. Anyone? To write down command. Command compulsory except comment. Okay, different Okay. This is comment This is comment. Okay, comment. Kalau comment, okay, refer again to the program. Okay, this is comment Okay, this is comment. So not necessary Okay, not necessary. Okay, like for this one okay, not included. That one for information purpose the purpose of comment. The purpose of comment is that to indicate, to give information okay, so that maybe you are writing too many programs, you don't know what is the function of specific code. Okay, you put on command. Comment. Comment. You put comment, so that it will give you information. Yeah. But for command, this is command. Okay. You need to. It is compulsory. According to the purpose of your program. Okay. If you want your program to light up LED, so make sure that the command is written will behave. Where the output is created, it will behave according to what you want your program, to what you desire your program to do. That one is compulsory, but this one not compulsory, but it is encouraged for you to write down command.